Another is to use the built-in arrays. I know in C# there's an array class, a round bracket array class that has a lot of tools that let you add, push, and pop and do other things with it. The built-in arrays don't have those tools. They're fixed size. We have to specify a size, and this makes them much more efficient in that they're directly embedded in a packed buffer with various type information. So they're much faster to iterate through than an ordinary array. These are just the square bracket arrays. So here in awake, I set positions to be a new vector 3 100, and then I can iterate through that very quickly. And this is very efficient. So use these square bracket arrays if possible. Now, another optimization is to perform less work, just do less. So for example, if we have some AI enemy that's out there, and most of the time it's far from our character, and it's perfectly acceptable to have that enemy fall asleep and not consume cycles constantly searching for its character. So that is, we do nothing unless the player is close enough that we want to interact with the player. Now, a slow way of handling this would be in the update function of our enemy that's going to test the distance to the target, the distance from the AI to its target. And if it's greater than some distance, we'll just abandon the update function and we won't do anything unless we're close enough. Unfortunately, this is not a good idea because the distance function is finding the magnitude of a vector. It's doing 3 multiplies, 2 adds, and a square root. And so even though this removes some of the real work of running our AI, we're still doing a considerable amount of work in the update. So there are a number of different solutions to this. One of the ways to do it is to use 2 functions, the on became visible and the on became invisible. We can also use triggers, or we can use coroutines, which I'll talk about. So on became visible and invisible are 2 functions that are tied to the rendering system. If any camera can see the object, on became invisible is called. When no camera can see it, on became invisible is called. And so we can have an AI that goes to sleep. We set it's enabled to be true or false, depending whether it's visible. And so that AI script will go to sleep if it's not visible in any camera. This, of course, would not work very well if you only had the first-person camera and you turned away from the AI. Then it would be invisible and it would go to sleep. So all you'd have to do is turn your back on the AI and it would go to sleep. If you have an overhead camera, that overhead camera is going to see your AI and do it. So that might be another way to give a greater range to the AI. Another simple way to do it is to use triggers. We can put a sphere trigger or a box trigger in a collider in our world that surrounds the area in which we want the AI to be active. And then with an on trigger, enter or exit, we can test to see if the collider that has entered or exits is our player, and we can enable or disable the script as appropriate. That way, when you walk into the box collider, the AI will become awake. Another is to use the coroutines. These are those magic functions that I've alluded to that allow you to wait for a certain number of seconds. And so we can use a coroutine to have the AI only check the distance to the player, say every 5 seconds or every 1 second. All of this would save a lot of processing power. In the update function, checking the distance, it's happening every frame, 60 times per second. If we have it happen every 1/10 of a second or every half second, that reduces the number of distance tests that we have to do by a whole lot. So a distance coroutine, in my awake function, I'm going to start that coroutine. Start coroutine, the name of the function and its arguments. Coroutines are this special type I enumerator. And because they're I enumerators, they can contain the yield statement. Yield, return, new, wait for some number of seconds. That is my argument here. That is my public float, how long I want to wait between tests of the distance to our target. The my distance routine is in a while true loop, so it's spinning continuously here, waiting a certain number of seconds, testing the distance, and then presumably doing whatever it is it has to do if it's within a certain distance of it. So here's an example of that. Here's an example of that. I have a distance tester that's doing it every frame. That's the update here that's continually testing my distance. And I have the coroutine version that's doing it every so often. And I have the little line, the draw line that's showing the vector between my character and my and the target. And you notice that every so often the red line updates, whereas the white line is being updated continuously. And this is taking a huge load off the AI that's testing that distance.